Question 27. P is a point on a circle with centre 0. We know the coordinates of P are -1, 4. We need to work out the equation of the tangent to the circle at P, given our answer in the form y is equal to mx plus c. So the first thing we need to do is we need to draw a line OP. So that's a line that goes from O to P. Let's draw that in right. Okay, so now that is the radius to this circle, and this is a tangent to the circle, so we know the angle between OP and the tangent is going to be 90 degrees. So the radius and the tangent are perpendicular to each other. So our first job here is we need to work out what the gradient of the line OP is. So we can say, well, we know that it's going to be, the change in y divided by the change in x. So let's call that, we're going to call that the gradient of OP, and that's going to be the change in y. So that's going to be 4, and the change in x, which is going to be -1. So that's going to be 4 divided by -1, which I know is going to be -4. So that's going to be the gradient of OP. So that means that the gradient of my tangent, which I'm going to call M with a subscript of t, that's my tangent, and that's going to be equal to, well, it's the negative reciprocal of the gradient here, because they're perpendicular to each other. So the negative reciprocal of -4 is going to be a quarter. So the gradient of this line here is a quarter. I can now write down the general equation for this. So it's going to be y is equal to a quarter x plus c. Right, now I know that it goes through the point -1, 4, so I know when x is equal to -1, y is equal to 4, so I can use that to work out the particular solution for this, for when it goes through that point. So at the moment this is all of the lines that have a gradient of a quarter. So when x is equal to -1, y is equal to 4. So I can substitute that information in to work out what c is. So 4 is equal to a quarter times -1, which is -1/4, plus c. So 4 plus a quarter must be equal to c. So remember, 4 is 16 quarters. So 16 quarters plus 1/4 is going to give me 17 quarters. So that tells me that c is going to be equal to 17 quarters. Right, so now I know what c is. I can substitute it into this equation here. I get y is equal to a quarter x plus 17 quarters. So we've been asked to give our answer in the form y equals mx plus c. So I'm not going to tidy this up. I'm going to leave it as it is, as y is equal to 1/4 of x plus 17 quarters. You could have given your answer as y is equal to 0.25x plus 4.25, and that would have been okay as well. Question 28. We're told the volume of a cone is 1/3 pi r squared h, whereas the radius and h is the perpendicular height. A cone has a horizontal base of radius 5 centimeters and a height of 15 centimeters. The cone contains water to a depth of 9 centimeters. We need to work out the volume of the water in centimeters cubed, and given our answer in terms of pi. So, first of all, we know the volume of the cone, so I should be able to work out the volume of this big cone using that formula. Over here, the shape that we have that is actually full of water is not a cone, it's a what's called a frustum. And in order to work out the volume of that, I need to take this big cone that I can work out, and I also want to take this little cone that I should be able to work out, and take that away from the big cone. So I'm going to do the big cone, take away the little cone, and that will give me this grey shaded bit that's left. Now the information that I've got missing is the dimensions of this little cone. I know that the overall height is 15, and I know here we've got a height of 9, so I should be able to work out the height here of the little cone. So 15 take away 9, which is 6, so that's going to be 6 centimeters. So that's going to be the height of the cone. Now the radius of the little cone, well, the radius of the big cone is 5, and because the little cone and the big cone are going to be similar to each other, if this big cone has a height of 15 and its radius is 5, we can see that the big cone's height is 3 times its radius. So that relationship should be the same in the little cone as well, because they're similar. So the radius of this little cone must keep the same proportion as the big cone. So if that's 3 times bigger than that, then this must be 3 times bigger than this. So this here must be 2 centimeters. Okay, 2 times 3 is 6, in the same way 5 times 3 is 15. And that's because they're similar cones. So we've now got the information that we need to be able to work this out. So the volume of the big cone, first of all, is, so let's see, volume of big is going to be equal to 1/3 of pi times the radius squared. So the radius is 5, so it's going to be times by 5 squared times by the height, which is 15. Okay, so that's going to be equal to, well, we can do 1/3 of 15 is 5, so that's going to be pi times 5 squared times 5. So pi times 25 times 5, so that's going to be 125 pi. Okay, so that's going to be the volume of my big cone. So the volume of the small cone, well, that's going to be 1/3 of pi times the radius squared, which is going to be 2 squared, times by the height, which is 6. And that's going to be equal to, well, 1/3 of 6 is 2. So we've got pi times 2 squared times 2. So that's going to be 4 times 2, which is 8. So that's going to be 8 pi. So remember what we said, that we need to work out the volume of the shaded part. So that's going to be the big cone take away the small cone. So volume of big take away volume of small is going to be equal to 125 pi take away 8 pi, which is equal to 117 pi. And that should be our answer there, 117 pi centimeters cubed. Question 29. We need to simplify 2 sine 45 take away tan 45 divided by 4 tan 60. Given our answer in the form root a take away root b divided by c, where a, b and c are integers. Now, in order to solve problems like this, a useful thing for you to do is, well, try and memorize what your sine, cosine and tan are of 0, 30, 45, 60 and 90 degrees, first of all. But if you struggle to memorize those, it's useful to be able to draw out an equilateral triangle, an isosceles triangle, and be able to derive what these are yourself. So I'm just going to talk through that part of it very quickly here. So this is an equilateral triangle. We're going to call this side 2, and because it's equilateral, all the lengths will be 2. I've cut this side in half, so that's going to be 1. We've got a right angle here. We know this angle here is going to be 60 degrees because it's an equilateral triangle. I know this angle here is going to be 30 degrees because that's half of 60 degrees. And using Pythagoras, I should be able to work out this length here, because it's going to be 2 squared take away 1 squared square rooted. So that's 4 take away 1, which is 3, So that there is going to be root 3. Over here, I've got a 90 degree over here. This is an isosceles right angle triangle, so that's going to be 1, that's going to be 1. That angle there is going to be 45 degrees. 45 degrees. And 1 squared plus 1 squared square rooted is root 2, and that's going to be that length there. So get into the habit of being able to draw these triangles, and that will help you to solve questions like this. Okay, so now we need to simplify this. So let's start with a 2 sine 45 degrees. So the sine of 45 degrees is going to be the sine of this angle here, which is going to be opposite divided by hypotenuse. So that's going to be 1 divided by root 2. So over here, I'm going to have 2 sine 45, and that's going to be 2 times 1 divided by root 2. And I'm going to take away the tan of 45 degrees, so we can use this angle over here again, and this time it's going to be opposite divided by adjacent. So 1 divided by 1 is 1, so that's just going to be take away 1. And we want to divide that by 4 tan of 60 degrees. So we can use this angle over here. The tan of 60 degrees is going to be the opposite divided by the adjacent again. So that's going to be root 3 divided by 1, which is just root 3. So 4 times root 3. 4 root 3. Okay, so in order to simplify this part, first of all, I've got 2 divided by root 2. In fact, we'll write that down. So I've got 2 divided by root 2, because that's going to be 2 lots of 1 root 2. Take away 1 divided by 4 root 3. Now, I can rationalize the denominator over here. So if I multiply the top and the bottom by root 2, that's going to become 2 root 2 divided by root 2 times root 2, which is 2. So that's going to be equal to 2 root 2 divided by 2. So that's the same as that. Take away 1 divided by 4 root 3. So just to clarify what I've done there, I've rationalized the denominator. I've multiplied the denominator and the numerator by root 2 by the same number. Root 2 times root 2 is 2. 2 times root 2 is 2 root 2. So this again simplifies, because 2 root 2 divided by 2 is just going to be 1 root 2. In the same way, 2x divided by 2 would just be 1x. So that's going to be root 2 take away 1. So I'll come over here. Root 2 take away 1 divided by 4 root 3. Okay, we've not yet got it in this form though, because I need this to be a rational number on the bottom. So I'm going to rationalize the denominator over here now. I'm going to multiply the denominator and the numerator by root 3. Okay, so I'm going to times both by root 3. So we need to be careful here, because I'm multiplying root 2 by root 3, and I'm also multiplying the negative 1 by root 3 as well. So root 2 times root 3 is going to be root 6. Negative 1 times root 3 is going to be take away root 3. So that's the numerator taken care of. The denominator, I've got 4 root 3 times root 3. So root 3 times root 3 is 3. So that's going to be 4 times 3, which is 12. Okay. So, and now I've got it in the form that I want, because I've got it in the form root a take away root b divided by c, and I've got root 6 take away root 3 divided by 12, and that should be my answer. And there you go. Thanks very much for joining me. I'll see you next time.